Let's finish up our discussion of XML by going over some best practices. XML variables and columns expose methods to make querying and modifying the data more straightforward. There are multiple types of indexes that can exist on XML columns, and if you create them appropriately, overall performance should increase. You need to ask yourself this question though when designing your database. Should I use XML or not use XML? So let's consider that. We know that XML columns can store up to 2 gigabytes of data. So why not store everything in XML? If we really need to store data in a platform-independent format, XML might be the best choice. But XML is not the easiest data type to work with. So even with platform independence and ease of portability, it might not be the appropriate choice. Here are some things you should consider when deciding whether or not to store XML in native format. Will the data structure change frequently and significantly over time? Is the data recursive in nature? And this is important because the data structure is the basis for the majority of your queries and updates. Is it important that the data order is inherent? Is the data that you're trying to model complex and difficult to do so relationally? If you determine that storing some of the data in XML is a good idea, there are additional benefits that SQL Server can take advantage of. You can directly query and update the XML data, and you can use schemas to validate your data. Highly structured data with little or no schema changes works best with the classic relational model. And truth be known, most situations require some sort of blended approach. For example, the complete XML exists in an XML data type column, but you might take data that's key to your querying and put them in standard relational columns. Here are some reasons to index XML columns. We hope that they'll improve performance, but we have to keep in mind that it's not a guarantee. If you're doing a lot of querying against XML columns, then the indexes may help. Keep in mind that frequent updates to indexed XML columns is going to incur an additional cost for maintaining those indexes. Remember that SQL Server supports 3 types of indexes on XML columns: primary, secondary, and new with Service Pack 1, the selective XML index. Some guidelines when choosing a primary XML index are: the primary index will index all tags, values, and paths. The base table has a clustered index on the primary key, and SQL will use the primary key to associate rows within the base table to their corresponding index row. Avoid using select star. SQL Server returns all of the stored XML. Remember that secondary XML indexes actually have 3 different forms: path, property, and value. When you're using secondary XML indexes, consider these points. A primary index must already exist on the column. If your XML queries use path expressions, creating a secondary path index will most likely increase your performance. Path-type secondary indexes improve performance when you use the exist method of an XML column frequently. And if your queries retrieve multiple values using path expressions, using a secondary property index may actually increase performance. Queries that search for values within XML data, but without knowledge of the elements or attributes, may benefit from a value type secondary index. What are some of the advantages of the new selective XML index? They may result in improved query performance for XML data type queries. That's because there's reduced storage requirements for those indexes. There's also reduced maintenance costs when you compare that to an ordinary XML index. If you need to support unknown elements or unknown locations within your document structure, then the XML selective index is not for you. And remember, selective XML indexes work by mapping out specific nodes. but if you're going to map out a great deal of nodes, you're actually going to reduce your query performance. So this is really meant for a relatively small number of node paths. If you're querying XML data and you generate an XML type result to use for further querying, make sure you issue the type option in a select for XML statement. Using the type option, you can assign the result to an XML type variable and then pass that variable to functions and stored procedures for further processing. You can use the for XML clause to create hierarchical results. If a simple nested approach is acceptable, avoid using the for XML explicit because it requires you to define the result set structure. OpenXML uses work tables instead of SQL's query processor. And OpenXML does not use the XQuery engine, but rather XPath and MSXML. SQL Server doesn't share those work tables with multiple calls to OpenXML, and this will limit the scalability. When used in conjunction, the nodes and value methods of the XML data type variable and columns may be the most efficient approach. Combining the use of those two methods makes better use of any defined XML indexes and may provide greater scalability than OpenXML.